I'm Kristof. I'm one of the co-authors of ERC 437. I'm also the founder of Pimlico. Pimlico is an account abstraction infrastructure platform where we provide ERC 437 bundlers, paymasters, and we are also the builders and maintainers of permissionless.js, which is a TypeScript library intended to give a full stack solution for account abstraction to end users. I feel like there's three main things that can be done to still increase smart account adoption. One is driving down the cost of user operations. So it's quite a big problem right now that using ERC 437 smart accounts has a significant overhead for the end user when it comes to how much gas fees that they pay. User operation compression is an interesting solution to this, where on rollups, you're able to compress the quality of user operations, which can make them significantly cheaper. And potentially, if there's enough volume, even cheaper than regular EOA transactions. That's one. The second is more tooling, right? We've seen time and time again that the most important reason a standard takes off or doesn't is to do with how much good developer tooling there is for developers to use. Without that, it's way too cumbersome for devs to try and implement the standards, to try and work with it, and to build on top of it. And finally, I think more standardization is very crucial still for smart account adoption. So there's a lot of really amazing standards, such as ERC 7579 and ERC 7555, which allow respectively for more modularization of smart accounts, as well as better SSO logins for smart accounts. Without this, it's quite cumbersome for dApps to try and implement smart accounts and still make it very usable for average users. As of this recording, the EntryPoint is currently at version 0.6. However, by the time this goes out, EntryPoint v version 0.7 will have been released, and there's quite a few changes to that. The most crucial, the most important ones, I think, are one, that the user operation struct is actually changing. So specifically, there's going to be several new gas limit variables introduced in the user operation struct. This is going to allow us to specify the gas limits for verification for paymasters, as well as the gas limits for the post-op call for paymasters as well. Previously, the verification gas limits for the account also served as the gas limit for the paymaster calls. Now, users can have a lot more specific control over how much gas they're willing to spend for each of these actions. Second is there's a new, very, very interesting delegate and revert function added to the EntryPoint contract. Previously, all the simulation functions of the EntryPoint were baked into the contract itself, but now with delegate and revert, the bundler is able to simulate and write custom simulation contracts that they can use to calculate the gas limits for these operations. Now, this allows for a lot more creativity for bundlers on how they calculate gas limits, and also solves a lot of bugs that bundlers have faced previously. Specifically, bundlers have had to use code overrides during the ETH call methods to actually simulate custom simulation contracts, and many of the chains, many of the RPC providers on these chains did not support correct code overrides. So that was a sustained bug, sustained annoyance that bundlers have had to face. And the final thing I'll mention is better incentive alignment by having 10% of the unused call gas limit slashed from the user. Previously, there was a lot of issues faced by bundlers where users would set a very high call gas limit, and this would require bundlers to take up a lot of space in the transaction when they submit it to blocks, meaning they could include fewer user operations. And now they're going to be incentivized to reduce the call gas limit to as low as possible so that they don't waste gas. One of the most promising ways to reduce the cost of user operations is bundle compression. So on rollups, quality cost comprises the vast majority of the cost of submitting user operations on chain, as opposed to the execution cost. Bundle compression works by introducing a special bundle bulker contract that the bundler will submit user operations to instead of directly to the entry point. This bundle bulker contract will then call the specified inflator contract, and this compressed call data will be inflated on-chain and submitted directly to the entry point. What this means is now, instead of submitting the completely inflated user operation to the entry point directly, the user is now going to submit compressed bytes with whatever compression mechanism that they see fit through this bundle bulker contract, which will then inflate it and submit it to the entry point, saving the user a lot in call data fees. Actually, it makes it possible to save up to 20 to 30% of the call data fees for generalized compression, and potentially even 80% or more of the fees for very specialized compression. A paymaster is a special on-chain contract that the user is able to delegate gas fee payments to in their user operation flow. The paymaster works by implementing a special validate paymaster user op function, which takes in the user operation struct as well as the amount of gas fees that would need to be sponsored. Inside this function, the paymaster would typically validate some special conditions under which they will decide if they want to sponsor this user operation or not, and then pay for the gas fees of the user operation instead of the account. If they pay for the gas fees, the smart account itself will actually not be required to pay any gas fees at all, and all the gas fees are sponsored by this third-party contract. There's many different ways of leveraging. Currently, there's two popular ways of using paymasters. One is a so-called verifying paymaster. Verifying paymasters allow you to load up a balance off-chain with crypto or credit card or in whatever mechanism you wish to a third-party provider. And then when you're looking to have your user operation sponsored, you would submit a special request for that provider to sign the user operation struct. On-chain, the verifying paymaster contract would then verify that this special provider's private key signed over this user operation. And if it did, it would then sponsor the gas fees for it. There's also many ERC20 paymaster implementations. ERC20 paymaster implementations allow users to pay with ERC20 tokens like USDC for the gas fees of the user operation. Since the launch of ERC 4437, there are many other standards built on top of this standard. Some more popular examples are ERC 7579, which proposes a way to achieve minimal modular account abstraction. It defines the interfaces through which modules and accounts should work, allowing for things like executor modules, custom validation modules, custom hooks, and means that any modules using this standard are able to plug into any of the different account implementations that are compatible. Other examples are ERC 6900, which allow for, again, a more modular version of account abstraction, and also ERC 7555, which allows for smart account SSO, a way to make it easier to log in with smart accounts to dApps in a way that does not lead to a lot of account fragmentation for end users. There's actually other standards as well, which are not directly built on ERC 4337, but have great compatibility and can make smart accounts even more usable. So examples of this are ERC 1271, which allows for a way for smart accounts to sign over custom messages, as well as ERC 6942, which allows for a way to have counterfactual accounts that have not been deployed yet to sign messages. Having these standards be supported by dApps is very crucial to the adoption of smart accounts. There's two very interesting ERC standards that can help us avoid fragmentation in the smart account space. One is ERC 7555. Previously, the standard way for dApps to start using smart accounts and giving smart accounts to end users was to generate a new smart account for every single user who used the dApp. Now, the issue was, what happens if the user goes to a different dApp, right? In each of these cases, a separate smart account would be created for the user for every single dApp that they visit. This means they don't have a standard, a persistent identity. It's difficult for them to maintain the assets that they have and they use with different dApps, and leads to a lot of fragmentation for this user, not a great user experience. ELC 7555 proposes a standard way of achieving SSO for smart accounts, basically a way to allow users to log in and for them to signal what smart account they want to use with this decentralized application. Another standard which is worth mentioning that avoids fragmentation is ELC 7579. This standard proposes a standard interface that modules can implement, which allows for different types of interesting use cases, such as defining custom account limits, defining custom signature schemes, different ways to log into your account, making it so that each of these modules that's written with the standard is actually compatible with all of the existing smart account standards also implementing this interface. This means that you can create one module and have it be usable across all the different smart account implementations. There are many popular libraries and pieces of tooling that developers can already use to get started with account abstraction. Some examples of these pieces of tooling are permissions.js, made by us at Pimlico, user.js, made by StackUp, and AccountKit, made by Alchemy. Many of the other libraries leverage one of these SDKs to allow for a very easy interface for developers, allowing them to get started with smart accounts and giving their users all the benefits of account abstraction. Permissions.js and AccountKit are built on VM and WAGMI, making it easy for developers already having existing WAGMI apps to migrate to allowing the users to have smart accounts. User.js right now is built with Ethers.js, making it very easy for developers who have built their dApps with Ethers.js to get started with smart accounts. ELC 7555 works by providing a way to log in with standard SSO, allowing users to choose what smart account they want to use when they log in to a dApp. The way this works is that when a user wants to connect to a dApp, the dApp is going to propose some SSO providers that the user can use to log in. There might be some standard ones from popular implementations, and users should also be able to choose their own custom SSO provider. So for example, I might have sso.kristofgajo.com as my SSO provider where I will host my own SSO solution. If I click this, if I select this, I'll be redirected to this website, and this custom provider website will prompt me with some checks, such as a Face ID check or a password or a passkey login. And after I have succeeded with this login, it will redirect me back to the existing dApp. And by authorizing this callback, the provider will signal what smart account address I will want to use. Moving forward, there's going to be a lot of very interesting standards to look out for. An example is RIP 7560, which proposes a way to achieve native account abstraction specifically on rollups. So currently, ELC 457 is a standard that's built on top of the existing EVM infrastructure. This means that there's additional gas cost associated with using user operations because all the logic for validation has to live on-chain smart contracts. With native account abstraction, it's going to be possible to get rid of that cost and make it a lot more safe for bundlers to submit user operations. It's worth noting that in all likelihood, bundlers will actually become part of block builders at this stage. So there's not going to be separate bundler providers. Another interesting standard to watch out for is a way to migrate existing EOAs to smart accounts. A big problem that we have seen is that the reason people don't want to switch from EOA accounts to smart accounts is that they already have all their assets on these EOAs. They might even have soulbound tokens, which they literally cannot migrate even if they wanted to. EIP 7377 proposes a way to migrate EOAs to smart accounts by introducing a new transaction type where the user can specify the custom implementation they want to use and having that be what the user is migrated to after the transaction is done. EIP 5003 would leverage the new opcodes, specifically auth and auth call, that EIP 3074 introduces to make this migration step easier. Luckily, there's already a lot of tooling support for 1271. For instance, VM already supports checking ERC 1271 signatures from smart accounts, and also many of the most popular smart contract libraries, such as OpenZeppelin, provide you a very easy way to check both EOA signatures as well as smart account signatures. Other standards to look out for that to be compatible with are ERC 6942, which allows for a way for counterfactual smart accounts that have not been deployed yet to sign over messages as well. If you want to give users smart accounts and not just be compatible with smart accounts, definitely take a look at some of the most popular libraries such as permissionless.js, AccountKit, and useorb.js, which allow for very easy ways to embed smart accounts into your already existing applications.